Good morning if you're in the UK. Good afternoon if you're not in the UK or somewhere else in Europe. My name is Paul Avison. I'm a solutions engineer for VIAVI Solutions. And I've been given the opportunity today to spend a little bit of time talking about our new MAP 300 platform and some of the new modules that we've been working on. So MAP 300 is our new platform, and it replaces rather imaginatively the MAP 200. And it's new for 2020, so it's something that we've been working on for a while, but we've introduced this year. So this is actually our third generation of MAP platform. So we introduced the first generation back in around 2001, second generation in about 2010, and this is our third generation. So even though it looks relatively similar, there's only so much you can do with an 8-slot modular system. It's actually quite radically different from the MAP 200. So there's a couple of different versions that you can see on the screen. So there is an 8-slot and there is a 3-slot as the base versions, and then each of those versions is available in a benchtop or a rack mount. The 3-slot is actually a standard half rack, so you can fit two side by side in a 19-inch rack. And the 8-slot can also be had with a reverse mounted, so the fibers come out the back. There is an optional touchscreen, so that can be attached to the benchtop, or it can be mounted separately for the 8-slot. So one thing we were very conscious of and very careful of is that we wanted this to be backwards compatible with the MAP 200 in a couple of ways. So one way is all the remote commands, all the Skippy commands are backwards compatible. So if you have automation written for 200, it will be compatible with 300. But also the current MAP 200 modules are absolutely compatible with the MAP 300. So you can just take out your MAP 200 modules and just pop them in the MAP 300. So we've retained the field serviceable power supply or field replaceable power supply and a single board computer. And then the big change that you'll see once you start to control it is that the user interface is really quite different and quite sophisticated. So it's an HTML5 GUI that we've enabled on this system. So another thing that you'd see when you first looked at the system is there is a small screen on the front, and this is what we call the local management interface or the housekeeping screen. So if you touch the screen, what you'll see is some system information, and there's a number of functions, basic functions that you can do with this screen. So probably the most useful thing that you can do with this is go into the network settings, and you can set the IP address, set it for dynamic or static IP addresses. And you can always see the IP address in the bottom left-hand corner of the screen. So you don't need to plug in a monitor to be able to see this. Amongst a few other things, what you can also do is you can do all the firmware updates on this local screen. So the updates of the cassettes and also the updates of the chassis itself. Okay, so we consider the modules that go into the MAP 300 kind of a toolbox for our customers. There's two main families. So the LightDirect is our point solution modules. So it's our simpler modules that have a single function. Our LightTest modules are often groups of modules that are bundled together to do something that's more complex. So for example, we can add our return loss module to switches to do insertion loss, return loss testing of MPO connectors, for example. Okay, so LightDirect modules are our basic foundational test modules. There's four main groups. So light sources, and we have a few new ones, and amplifiers, power measurement, so lots of different types of power meters, a spectrum analyzer, and then switching and routing. So incredibly important for our customers is the ability to do parallel testing. So it is surprising how useful switching is to our customers. So we have a big range of switches, and we have a new one that I want to show you today. And then signal conditioning is where we actually degrade the signal. So for example, we would add attenuation, or we would do polarization control, or we would add back reflection to the signal. So these are basically characterized by a relatively simple user interface and very simple Skippy commands. So for example, a switch is just a root close command. Okay, and we've been working on making these things faster, often by using the trigger function. So we have the ability to trigger in hardware rather than over the remote interface. Okay, so a couple of different enhancements to some of the very standard LightDirect modules. So on the attenuator, the MVOA, we now have this some hardware triggering from the back panel. The main application for that is doing loss of signal. So our customers have been telling us we want a very precise test mode that gives us a loss of signal for a period of time, either a single loss of signal or a series of loss of signals. So we now have the ability to create those test modes with millisecond resolution. We've also added some power control modes. So we do have power control attenuators with built-in power meters, but we've added some new modes where we can actually use standard attenuators and use external power meters alongside those standard attenuators. A big addition to the power meter line is what we call our integrating sphere version. So instead of having a separate integrating sphere, this has an integrating sphere built into the power meter. So the applications for that are really native measurement of power for multi-fiber connectors, but also it works extremely well for single fiber, particularly for unconnectorized fiber, so bare fiber. What we've also done is we've released an application called OPM scope. So this uses the relatively fast power meters, so they have storage on the power meters, and it releases that ability to take that storage from the power meter and actually transfer that into Excel. So if you're measuring transients in power, so particularly if you're doing things like drop testing, any kind of cable testing that requires an event, we have the ability to take that stored power data and transfer that into Excel, for example. So that's now available on map 300 as well as map 200. So on some of the more interesting modules, we've got a couple of new variants of the polarization controller. So we've seen a lot of work in the O band, so the 1310 band. So we now have a full O band version. What we've also added is a simpler version. So the standard version does polarization control, polarization scrambling, and we've just added a simpler polarization scrambler. So it takes away the polarization control. So if somebody only wants scrambling, that would be what they would buy. We've introduced another new module, which is our variable back reflector module. So this is particularly geared towards some of the new specifications for 400 gig coherent. So these standards call out requirements for injecting back reflection into the port of the module. So the variable back reflector is a calibrated, dynamic variable back reflector that will cater for those clauses in the specifications. There's a number of new light sources. So the headline one, I think, is our new tunable laser. So it's quite powerful. It's very narrow band. It works in the C and L band, and we think it's pretty much the most compact on the market for its performance class. So it's a high performance tunable laser, but it's relatively compact. So it's a 3-slot module that would go into the MAP 300. So there's a number of other sources. So we've introduced, I think, 6 new CW sources. So, and these include telecom telemetry wavelengths. We've got some new O-band additions, including DFB and a high power O-band SLED as well. So a number of new additions to the high performance source line. Okay, so the kind of the headline in this LightDirect range is what we call the X series. So the X series is a new series of modules, or a series of modules that have been around a year or two. So from the left-hand side, the MOSX is our new matrix switch. So I'm not going to go into too much detail on this, but basically there's 2 versions with different fiber connectors, but there's a 16 fiber version and a 32 fiber version. And those are simple in operation. So it's any port to any other port. So it's traditional matrix switches tend to be N by N. So you have an input side and you have an output side. These don't have that. They just connect any port to any other port with no restrictions. And then in the center you have the TFX, which is our tunable filter. It's actually a lot more complex than that. So it's more of a complete wavelength management layer. So, and I'll go into a little bit more detail in a moment. And then the PCX is our polarization controller. Okay, so what does the tunable filter do? Well, it's actually a packaged wavelength selective switch. And essentially what it does is it will send any slice of spectrum to any port. And of course it's bidirectional, so it'll work you can bring in a slice of spectrum into a port and send it to the common port. So it's a packaged WSS. But instead of having to control the liquid crystal slices in the WSS yourselves, we actually have done all that work for you. So when you say, I'd like to send this portion of the spectrum to port number 1, that's all done on our software on the back end. So we will manage the shape and the loss of those slices. So it does a number of things. You can mux and demux light, and I'll show you an example in a moment. You can attenuate the light as well. You can switch the light around. You can actually add arbitrary shapes. So for example, a gain flattening filter. And we've actually added some power measurement as well. So for example, if you send a slice to port number 9, then that has a power meter on it. So you can see what power level is in a particular slice of spectrum. So it's incredibly flexible as a module. It's as standard, it's 2 ports, but you can actually add licenses to go up to 4 ports and 8 ports. So it does a lot, but the actual interface is incredibly simple. So a couple of examples. On the left-hand side, you've got maybe a simulation of a channel going through a number of different nodes. So we set a channel width, we set an attenuation, and in this case, we are narrowing the channels as you go through multiple ROADM nodes, so the add-drop multiplexer nodes. On the right-hand side, we've just created an arbitrary filter shape. We've sent that to the filter, and within a second or so, the filter has then recreated that shape in wavelength or frequency in this case, and you can see the result of that on the right-hand side. Okay, on the polarization controller, so it does 3 things. So it's a polarization scrambler, it's a polarization controller, and it's also we also use it to stabilize a polarization state. So it is calibrated. It's also incredibly fast. So it actually will scramble it up to 3 megaradians per second. So size actually matters in this area, because an awful lot of our customers manufacture at contract manufacturers. So if we can save 50% in space, that actually matters in terms of renting space at contract manufacturers. So one of the big applications here is for, again, coherent detectors. So there are often particular polarization states that coherent detectors will struggle with. So our customers will drive the incoming signal to a particular state to try and stress their coherent receivers. So again, very advanced, but simple in operation. So just to give you a couple of examples, there are some standard scrambling modes. If we look at the second from the left, so the Rayleigh scrambling mode, this is a particular mode that's biased towards relatively low changes in state of polarization, but occasionally we'll actually just bump it up by a step just to simulate so it simulates the slow change in polarization in fiber, and then occasionally if a truck goes past, it'll jump quite a lot. So there's different scrambling modes built into the module. So kind of putting all that together, we've put together some examples for our customers to test coherent modules. So this is an example that actually is pretty much real world. So there are 4 different devices that this particular customer would be testing. So they're bringing in the, so these are all at different wavelengths. So they're actually just combining the 4 wavelengths, just using just a simple splitter and combiner. We're actually bringing in some noise, and we're controlling that noise. So it's an ASE source. We're controlling that noise with an attenuator, adding it with a coupler. We're actually adjusting the polarization state with our polarization controller. We're using a 2x2 switch to bring in a fiber spool. Of course, that could be a matrix switch where you bring in different, maybe you add some attenuation, you add a PMD element or a PDL element as well. And we're then going through another attenuator, another EDFA, where perhaps we want to overload the receiver. And then we're actually using our tunable filter module or our TFX module to separate those four devices into different ports. They go to the correct port at the receiver of the device under test. And then we also have connected our Coherent OSA as well, so our high resolution OSA. So the kind of the point about that is that this is actually a relatively complex but fairly standard test system for our customers, but we can actually fit it into a very small space. So this fits into just over an 8-slot chassis. So it would be an 8-slot chassis plus one of our 2-slot chassis as well. So it's really, really compact for what is actually a fairly complex test system. Okay, so a couple of other little bits. We've just released a sweat wavelength system. On our sweat wavelength system, we've just released a new laser. So traditionally, for the last few years, our laser has been a 19-inch rack 3U laser. We've actually just brought that into the MAP 300. So we have a 3-slot sweeping laser now in our MAP 300. What that actually enables is a full system with 4 detector modules, so 16 different detectors in a single 8-slot chassis. Okay, so that's it with the presentation. I'm just going to spend about another 1 minute, if it's okay, on just to show you what the GUI looks like on the MAP 300. So I'm just going to move to my browser, and just what you can see on the browser. I'm not going to spend an awful lot of time on this, but the browser is, so this is the GUI for the MAP 300 is HTML5. Whether that's a local GUI or whether that's a GUI that's just running on a browser. One of the nice things about this is it actually loads up an instance of the GUI inside the browser. So the system I'm actually using here is actually in Canada and I'm in the UK, but I'm using it as if it's next to me. So I've actually got an 8-slot here. So you can see there's an OSA module, there's a filter module, there's a matrix switch module, polarization controller, attenuator, EDFA, and some utility cassettes just with some splitters in. The important thing, and what I wanted to show you, is that we've got a lot more space to play with compared to the MAP 200. So if I'm, for instance, using the tunable filter, if I just click on that, I can make it much larger. And I'm now working on the tunable filter, but what was important to us is you can still see and control all the other modules at the same time. So if you expand one module and you're working with that module, you can actually see the effect of that, any changes in that module on the other cassettes as well. So really nice, up-to-date GUI. And that probably concludes where I wanted to go. So I'm going to stop sharing my screen for now, and I will answer any questions if we've got them.